Our adventure in math continues, but hold the presses. Things are changing as of today. We are moving away from just working with equations, and we are going to work with something called inequalities. Today, we are solving inequalities using addition and subtraction. Now, let's go back to what we've been doing. We have only been working with what is called equalities. That's where we have an equal sign in an equation, and this side of the equation always stays equal to this side of the equation. But not all math problems are equalities. We also have something called inequalities. Now, inequalities just means that we're replacing the equal sign with a less than, a greater than, a less than or equal to, or a greater than or equal to sign. But everything else stays the same. So when we take a look at our inequality problem, it contains a lot of the same components that we had with our equations. But the big difference is no longer am I staying in balance, I'm going to be out of balance. So everything we've learned up to this point still remains. I always start on the side of my inequality that has the variable, and my job is to gather all of my variables together and all of my constants together. Once I have those gathered, then I can solve my inequality. I look at this problem, and the first thing I notice is I see a subtraction. And I know that whenever I'm gathering like terms, it's often easier for us to see those like terms when we have an addition sign rather than a subtraction sign. So my first step is I'm going to change that subtraction to an addition. But I know the second I do that, I have to take the opposite of the number that directly follows that subtraction sign. So the opposite of a positive 26 is a negative 26. And I'm going to do that in red so that we can see the color of the integer sign. Now everything else stays the same. So I'm going to keep everything else on that side the way that it was. Now, all of my variables are gathered. I don't have to worry about my variables, but I have to worry about my constants. My constants have not been pulled together, and I have to pull all of those constants together into a single pen. So when I take a look at this, I see this is a positive 13, so those are my blacks. This is a negative 26, those are my reds. So when I go and I'm actually calculating that, I want to think about those zero pairs that are going to happen. So I have a positive 13 plus a negative 26. Well, I can see that I have far more reds than I do blacks. So when I pull those together, I'm going to have a lot of zero pairs, but my final answer is going to be negative. And I know that 13 of those blacks are going to cancel out 13 of those reds. So I'm really going to take my 26, I'm going to subtract those 13 to see what's left. I see I have a negative 13 or reds. So I know that I have n plus negative 13 on that side. I still have my inequality sign, and I have 38 on that side. Now when I go to solve, I don't want a plus a negative. So just like I did when I changed the subtraction to an addition, I can change an addition back to a subtraction. So I'm going to keep that n. I'm going to change that addition to a subtraction. I'm going to take the opposite of negative 13, which is 13. Everything else remains the same. Now I've got all my variables together. I've got all my constants together. Now I can solve my inequality. Now solving an inequality is no different than solving an equation. We're going to use inverse operations for that. So I start on the side that's my variable. I need to get rid of this minus 13. How do I get rid of it? I use my inverse operation. The inverse of it, subtraction, is addition. I'm going to add 13. But if I do it on one side, I have to do it on the other side. These I know will cancel out, and all I'm left with on this side is n. I keep my less than sign, and I have 38 plus 13. Well, 8 plus 3 is 11. 3, 4, 5, I get 51. Now here's the big difference with inequalities. I read it from the side of my variable. And what I say is all numbers that are less than 51. Well, there's an infinite number of numbers less than 51. So I have to show my answer differently with an inequality. And the way that we do that is we draw a number line. And you don't need the entire number line, you just need the number that you found in your inequality and a number on both sides. So I have 51, I have 52, and I have 50. Now, when we go to actually show our answer, we use what's called open circles and closed circles. If my answer is less than or greater than, and it's not equal to it, I use what's called an open circle. It means that number is not included in the answer, but the number right next to it, which would be like 51.000000000001 is a part of it. If I want 51 included in that answer, then I use what's called a closed circle, and I literally just color in that circle. So that equal sign makes us fill in the circle. If the equal sign is not there, we leave the circle open. So I see that I don't have an equal sign there. So I go to my 51 and I use an open circle. And I think, well, where are all the numbers that are less than 51? Well, it's got to go in the direction of the left part of this number line, and I just draw an arrow towards those numbers that would be all the answers. So the big difference with an inequality is how we show our answers. It has to be drawn on a number line, and that is called graphing an inequality. Now it's your turn.